Assalamualaikum and hi, my name is NAWWAL BINTI RADHI with the number metric T210047. So I am from group 5 and this is my team member, which is the first one is ARDINY HAMIDAH, the second one is me myself, the third one is SITI NURSYAKINAH Maisarah, the fourth one is UMMI RAIHANAH, and lastly is one Muhammad ARIF. So today we will present our project, which is a cost-effective solution in utilizing electrical energy system. So let's move to the introduction. A more recent government effort is embodied by the 11 Malaysia Plan, which promotes the adoption of sustainable energy practices to facilitate the nation development. One of its primary objectives is to enhance coordination of collaboration among stakeholders in the energy sector. So this involves establishing a more organized institutional partnership between different agencies involved in energy planning and actively involving consumers in adopting energy efficient consumption habits. Government, business, and individuals worldwide are increasingly embracing renewable energy to meet energy demands and sustainably and transitions toward a low carbon future. And renewable energy sources such as solar have significantly lower carbon emission compared to fossil fuel. And solar power harnesses the energy from the sunlight using PV cells or solar thermal collectors. And an electrical engineer must have sufficient knowledge of the design of electrical distribution circuit, the use of safety device, the calculation of cable diameter, and the assessment of the power consumption and elimination quality in order to construct an acceptable electrical system. So in addition, this assignment identifies how electrical is used and suggests ways to change the development process to reduce the cost using electricity. So this is our company background, which we name our company as SITI, which is a Bumiputra owned. So this is our company background, which we name our company as SESDM-BHD, which is a Bumiputra-owned electrical and project management consulting engineering firm that provides a wide range of energy efficiency and engineering planning and design, project and construction management service. And our SESDM-BHD takes pride in its strong in-house technical expertise, which is focused on providing innovative engineering solutions and sustainable energy to assist the nation development progress. So this is our group formation. The group leader is me, myself, Nawwal Binti Muhammad RADHI. Our secretary is UMMI RAIHANAH, and our group member is ARDINY HAMIDAH, SITI NURSYAKINAH Maisarah, and lastly is one Muhammad ARIF. So our group name is SESDM-BHD, and the group logo is there, and our group motto is generate, conserve, and contribute. So this is our organization chart, which is me, myself, is the CEO of the company. UMMI RAIHANAH is the general manager. ARDINY HAMIDAH is the director of human resources. And SITI NURSYAKINAH Maisarah is the director of plan and design. And lastly, one Muhammad ARIF is our director of sales and marketing. So this is the site visit summary, which the site visit survey was completed in accordance with the project, and details of the project site are mentioned below. So this is our place that we visit at which the place are at the Jalan Parit Jambul, Parit Raja 84600 Johor, and the attendees is UMMI RAIHANAH and SITI NURSYAKINAH Maisarah. So I think that's it from me. Let's move to the other person.
Hi and Assalamualaikum. My name is SITI NURSYAKINAH Maisarah binti ABDULLAH. My mention number is DE210103. So next is for summary of issues. In summary, as we know that the economic issues in this country was very crucial. For instance, in financial challenges, while ensuring the development of the houses, by putting cost-effective measure into the place, one can solve the economic problem and provide affordable homes. Other than that, we should also consider that beyond reducing greenhouse gas emission, energy efficiency in building has positive environmental effect. With the energy efficiency, is also consistent with environmental stewardship and sustainability goals. There are many possibilities for this company to improve the building energy efficiency, and many other features can be improved to raise its value. For instance, it involves evaluating the design ability to optimize energy consumption, reduce waste, and minimize the environmental impact. In addition, prioritizing energy efficiencies throughout buildings construction enables the implementation of new energy-saving measures. One of the most important goals of our company is to increase the building energy efficiency, and there are several ways to do this. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is ARIF bin KAMALUDIN, matric number DE210112. Next, for objective and scope of investigation. Okay, the objective is first is to identify and evaluate the potential site location for the housing development based on accessibility, infrastructure, ability, and environmental consideration. Second, to identify and evaluate current issues or difficulties with electrical energy used in the context of house development. Third is to develop an effective electrical system design to prioritize energy efficiency while taking cost effectiveness and environmental sustainability into account. And fourth is to analyze and optimize different electrical system components such as power generation, distribution, and consumption to reduce energy waste and increase efficiency. Next, for the scope, first, site location and building selection. Second, engineering innovation analysis and proposal. And third is electrical system design for energy efficiency.
Hi, Assalamualaikum. My name is ARDINY HAMIDAH binti Muhammad YUSOF. My metric number DE210105. So let's continue the next part, which is methodology. There are several parts need to be considered to fulfill this project. So the first one is we are doing meeting to discuss with our team about the suitable location that cost effective. Okay. Then we go for the site visit. We inspect the location, either it's perfect or not. If not perfect, we will do for another site visit, and then if it is okay, we move to the next part, which is determine the type of building for our house development. Okay, and then we go to the create the building plan, and we submit to our engineer to do some review. If the engineer rejected, we have to create another floor building plan. So if yes, we need to identify the requirement for the electrical points in each room, and we decide the rated capacity for each point in a room. We also need to calculate the load consumption estimation. Also, we have to divide the entire electric load into number of circuits. Okay. So after that, we have to determine the cable rating that we are using in this project. We design the single line diagram using software, and we estimate the cost, the suitable cost. Okay. So after that, we check either the cost saving or not. If no, we will check back the cable rating that we want to use for the system. If yes, the director will review the design and we will propose to the customer. So that's all for the methodology part, and then we will start the project development. Thank you.
Hi and Assalamualaikum. My name is SITI Maisarah binti ABDULLAH with metric number DE210103. So for my part, I will discuss about analysis and discussion. So first is for investigate suitable site location. This site project is located at Taman Melewa, Batu Pahat, Johor. It has 3 bedroom and 2 bathroom in total. So figure 6.1 show the construction of the building. So for figure 6.2, which is show the longitude and latitude of the location at Taman Melewa. So figure 6.1.3, which is show the street view of the site location. Next is for house design, which is this house has been designed by me myself, which is Dr. YUSOF Maisarah, by using SketchUp software. So figure 6.2.1, which is show the design of floor plan. So next is for house floor plan. We sketch using pencil and paper. So for this figure 6.3.1, which is house floor plan for IL, which is stand for indication lamp, we use 30 indication lamp in this floor plan, which is it produce more lumen and more power watt, which is can increase our power consumption in house. So for figure 6.3.2, which is house floor plan for LED, which is we change IL to LED to make sure we have we decrease the power watt, but the lumen of the LED still same with IL. So next is for single line diagram that we draw, which is this is for single line diagram. So we use first is kilowatt meter and then 60 ampere switch fuse 2 pole using 32 SPN MCCB and produce RCCB to RCCB, which is 32 ampere over 100 ampere. And in bedroom 1 and 2 we use 16 bedroom 1 and 2, bedroom 3 and living room and also dining room. We use 60 ampere. And for bedroom 1 and 2 we use 10 indication lamp and 2 ceiling fan. For bedroom 3 and living room we use 8 indication lamp and 2 ceiling fan. And for the dining room and bathroom we use 10 indication lamp, and for anjong we use 2 indication lamp. So next is for socket. We use 13 socket for 13 ampere, and we use 3 aircon using 1.0 HP and 2 water heater and 3 exhausted fan. So I think that's all for me. Thank you.
Assalamualaikum and hi, my name is RAIHANAH ROSLEE and my metric number is DE210061. So I will explain the load analysis in analysis and discussion. So for the first one, we want to comparison. If we use IL, which is incandescent lamp, and we use LED, light emitting diode. So for the first one, we apply the incandescent lamp. So we use the brand of Chioda incandescent light, 40 watt and 640 lumen. So the is list of IL that we are utilized in the house building. Firstly, we calculate the maximum demand to find the size of MCB and size of RCD. So the total maximum demand that we get is 4,278 watt. So the size of MCB we get 32 ampere MCB SPN, and size of RCD is 32 ampere. Then we calculate the power consumption per month to find the monthly bill per month. So we get the power usage which is 1158 kilowatt hour. Then the total of monthly bill we get 119.73 ringgit. So if we use light emitter diode, this is the list of LED that we utilize in the house building. So this is we find the maximum demand. The size of MCB and RCD is same, which is 32 ampere and 32 ampere for the RCD. So the power usage per month for LED is 947 kilo hour, and the total of monthly bill is 410.85 ringgit. So the comparison is the power consumption per day if we use IL is higher than we use LED, because if we can see here, the total the total unit of IL is 30 and the total unit of LED is 50, which is the IL 2 times higher than LED, but the value of lumen is slightly same. We can observe that the power used for LED is 947 kWh, is less than power used in IL. So due to the amount and type of LED that we selected, the house is more cost effective following the design that we made. Only 15 of LED lamps are required. So for the solar implementation, we want to choose the LED lamp. So we use the power usage per day in LED. So the new power consumption per day we get 22.11 kilowatt hour. So the total per month we get 663 kilowatt hour. So the new monthly bill we get 264.31 ringgit, which is half of the price before we implement the solar. We can say that it saves more money. So the energy saving, we decide to replace the incandescent lamp to LED because we can see a few advantage in if implement LED in the house. So the power required yearly is for the IL 13.90 kilowatt hour, for the LED 11.36 kilowatt hour. So we get the annual energy saving is 2.54 kilowatt hour. Then the replacement cost we get 180 ringgit. So for the payback period we get 4 months. Next, I will pass to the next presenter.
Okay, next for the conclusion. In conclusion, this project successfully achieved its objective and developing a comprehensive and cost-effective solution for utilizing electrical energy in a housing development while emphasizing energy efficiency and environmental sustainability. In addition, the project identified and examined current issues with the use of electrical energy in the context of housing developments, and it proposed creative technical solution with an emphasis on energy efficiency, load control, and the incorporation of renewable energy sources.